All right, so we're moving slowly but steadily through Unit 8. Um, and these are your objectives for day 3. I have to warn you that as the days go on, the notes do get more and more intense, and I might be splitting them up depending on how long it takes to complete the notes. Unit 9, a lot of those notes are so long. I wouldn't want it to be 2 hours long for you to kind of get the unit day out. So I might be have to like split those up and do like unit 8, day 1, part 1 type situation. But we will see. We will see as these notes start getting more and more intricate and more detailed. I will definitely play it by ear. But for this particular one, I think I want to try to get it, just do it in one take if I can. But again, we will have to see. I just wanted to kind of forewarn you that these notes are very long and it does take a lot. Sometimes I don't want you to have to sit for an hour to watch it or two, but I'll split them up. Okay, so these are the objectives for today. Unit 8, day 3. We're getting really into radicals now, and radical equations coming up, radical expressions coming up. So really make sure that you're in Alex, you are practicing. If you need any more extra help, of course, reach out to me. I am here to help you. I am not only here on these videos, I am actually here in person. You just email me cannon@tncc.edu if you have any questions. And of course, if you want to meet during my office hours, okay? Or sometimes even I have other times we can meet, so just reach out. So here we are. Assume that the variables represent positive numbers. We are simplifying here. So we kind of ended day 2 on the same vein. So we are going to, it's the square root, okay? So each of these will be kind of handled separately with the square root of 16. Hopefully you know it's 4. If not, put in your calculator. In this particular situation, I told you last time, I would subtract 1, put 1 by itself. Same thing here. Subtract 1, put 1 by itself, especially if you have just the square root. If you're doing this, you divide that by 2. The even numbers you divide by 2. So this becomes 4. T to the 8 divided by 2 is 4. And of course, this W 2 divided by 2 is 1. So I would just put a 1 there. All right, so my dog wanted to come in. I have to go get my dog. All right, so now let's go ahead and go to the next one. That is start. 54, square root of 54, square root of T to the 11th, and the square root of W to the 5th. All of those are kind of separate. For this particular one, of course, the 54 is not a perfect square, so we can kind of split that up. 54 is 9 times 6. Okay, square root of 9. We know that the square root of 9 actually is a perfect square, so we like that. That becomes 3. 6 doesn't have any perfect squares in it. It has 3 times 2, which doesn't equate to anything. So we know that that is the square root of 9 is 3. That's going to come out to be 3 on the outside. This right here, again, we would take it just like we did with the other ones. We'd make it basically like one even number and then put 1 by itself. So basically subtract 1 from here and put 1 by itself. Same thing here, subtract 1 from here and put 1 by itself. So this now becomes, on the outside is a 3 because the square root of 9 is 3. Here that becomes, if we divide that by 2, that becomes T to the 5th on the outside. Same thing here, that becomes W squared on the outside. So everything on the outside came out. What was left over is the 6, the T, and the W. All of those are left over inside. So this will be the square root of 6 TW on the inside. So all the outside basically numbers go all together. Inside of the square root numbers go all together. Okay? All right. So write the following in simplified radical form. Again, they want the answer in radical form, so they actually don't want a decimal. If you put it in your calculator and get an answer that's a decimal, let's see, 4, and then the 4th root of 80. That's basically what they're asking you for. Basically, something like that. And it came out to be a nasty decimal, so you can't put it in calculator. You got to kind of like break it down, and we'll try that on our own. So this becomes 4 times 20. Okay, I broke that down. But we're fourth root, not square root. So I'm going to break this down into 2 times 2. So it's not square root. 20 is 4 times 2. 4 times 5, sorry. 4 times 5. And then 4 is 2 times 2. So I basically broke this number down, and I usually put a little extra once I break it down to know that it's gone. So I'm not thinking, oh, this is 2 times 2 times 2 times 4 times da 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 da. So once I break it down, I put a little line through it so that I know that it's kind of gone and I've used it already to use it on these numbers here. So now, as you see, our gatekeeper's 4 here, okay, or our root number is 4. So we need 4 of the same number in order for it to come out one time. 1, 2, 3, 4. So basically we have 4 2s. 4 2s can come outside one time, okay? And then the 5 is left alone. So inside my fourth root, I still have a 5 that can't come out because it doesn't have any partners. So that would be my answer there, okay? All right, let's do the same thing here. I see a 25 and a 100, okay? And again, you can do this multiple ways. I know that once I break 25, I get 5 times 5. 100, there's multiple ways to break down 100. You can do 10 times 10. You can do, whatever way you feel comfortable doing. Then I have another 5 times 2 is 10, and then another 5 times 2 is 10 there, okay? So basically, I need 3 of the same in order for it to come out. So 1, 2, 3 5s there. So I know they're going to come out one time. Doesn't look like I have 3 of the same for it because there's a 2, a 5, and a 2 left over inside. So 1 5 came out, and what was left over was a 2 times a 5 times a 2. And 2 times 5 is 10. 10 times 2 is 20. So what's left over inside is 20. The 5 came out. So that would be my answer there in radical form. Okay. And again, it does take a lot of that math sense that you have to have kind of to figure these things out. Now, with this next section or next page, you are going to have the exponents here of 19, and you're raising it to the 4th power. So we're trying to figure out basically what is happening if I took 4 of those out. What is left over, what doesn't have any partners, whatever the situation is. So when you have an exponent, I usually do it this way. Again, you do not have to. Alex shows you a different way. I show you a different way, which is good because then you'll have multiple ways to figure out the problem, okay? To kind of figure out what's going on, and having as many strategies as you can is so helpful. So in this situation, we have 19. I usually do it this way where I'm dividing 4 into 19, and the remainder is going to be what's left over inside. So how many times does 4 go into 19? 4 times, okay? Because 4 times 4 is 16 without going over, of course. It's the old school way of dividing, okay? And then I'm going to subtract. 19 minus 16 becomes 3. So this right here is your remainder, okay? This number up here is going to be what goes on the outside. And your remainder, is going to be what's left over inside. And this right here is your root. All right. So what is it going to look like? Outside is 4. So there's going to be 4 V's. V to the 4th power is going to be on the outside. Okay, 4 V's came out. 4th root of 3 V's are left over inside. So this is your answer. All right, so I usually do it this way, again, just for exponents. Of course, the numbers are different. That's how we did the other numbers. They're pretty different. You have to kind of like break those down yourself. But that is how I do it. Whatever is left over on the inside, that's the remainder. This number that I get up here came out, and then that's your root, of course. So if I wanted to kind of show you like the actual situation of what went on, basically you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. So I have 19 B's. I'm going to, of course, this is my root. So I'm going to have 4. I have 4 here. 4 comes out one time. 1, 2. I did this kind of weird. 3 and 4. Okay. So 1, 2, 3, 4 came out. As you see, I have 3 that don't have enough to come out because there's only 4. The root is 4. So that's why it became 4 came out, 4 V's came out, and then the 4th root of what's left over is 4 cubed. So that's how I got that. You are not going to be able to do this. Sometimes you'll have 50 or 70 or something of that nature. You can't have these huge numbers. You don't want to have to write them all out. This is the best way. And the more you practice, the better it will get. Okay? All right, so 162, I'm sure 162 is probably not a perfect 4th, but I'll see because I always check. Okay, 4th root of 162. Oops, sorry, did that wrong. 4th root of 162, and of course it's not. So I'm going to have to break that down. I will start by dividing by 2. It's an even number, so I know that I can divide by 2 at very least. Okay, 2 by 81. And I know now 81 is 9 times 9, and that's 3 times 3. And that's 3 times 3. Okay, and you need 4. 1, 2, 3, 4. I know that 3 is going to come out 1, and that 2 is going to be left over inside. Now let me do y to the 11th. Okay, like I said, I usually divide that, whatever the root is, it goes out here, and I'm dividing by this exponent. How many times does 4 go into 11? 2. Because 3 would be 12, that'd be too big. 4 times 2 is 8. Subtract 11, 10, 9, 8, 7, 6, 5, 4, 3. 3 is your inside, out. 2 came out. Okay. Inside left over 3 Y's, 2 came out. So in this case, I said the 3 came out. Okay, it looks like the 2 is left over. 3 came out. 2 Y's came out. Y squared. 4th root of 3 are left inside, and it looks like a 2 is left inside. Okay, this little 2 is left, no partner. So 2y to the 3rd is left inside. Okay, and again, this can get very, very, very intricate, and it becomes like a lot of paper used really to make it so that you can kind of fit all this stuff inside. But that is my thought process. Practice. If you expect to understand this and you haven't seen this in years, or you feel like you've never seen this, you have to practice. It takes time, it takes effort, it takes practice to really, really feel comfortable with this stuff. Again, if it's the first time you're seeing it, or if you're seeing it on Alex and you really, really don't understand, you have to practice this stuff, okay? You don't become good at anything without practice. All right, let's go. Let's move here again. I would start, if this is an even number, I usually start by dividing by 2, but in this case, I'm going to divide by 4 because I can see 4 and 8 are both divisible by 4. So I'll be 12 and 4, 4 and 12, 3 and, what am I doing? 3, 2 and 2, of course, and this is not a square root, so it's a cube root. 12 is 4 times 3, and this is 2 times 2. Okay, so now, of course, I have 1, 2, 3, 4. Our gatekeeper score, I need the 4 of the same thing to come out 1 time. That came out 1, so the 2 will come out 1. Here, okay, if you have it raised to a power that is divisible, all you have to do is divide that by 4. Okay, 8 divided by 4 is 2. So t squared comes outside. In this case, because it was 8 divided by 4, you're still going to divide. You're going to have 18 divided by 4, okay? 4 is dividing into 18. How many times does 4 go into 18 without going over? 4 times 4 is 16. 4 times 5 is 20. So it's going to be 4. 5 is too big. 4 times 4 is 16. Subtract. 2 is inside. This one is outside. 2 are left inside. 4 came out. So let's put all of our outside numbers together. In this case, again, 2 came out. 3 was left over inside. Okay, so 2 came out because there are 4 2's. T squared, it came out because 8 divided by 4 became 2 for the t's. So it's t squared. And here, this one is the t, oh, that's the s's. I'm so sorry. So sorry. See, yeah, don't get those letters mixed up like I just did. These are the actual t's, okay? The s's became s squared. S squared. And the t's, again, 4 came out, so it's going to be t to the 4th, and it looks like 2 are left inside. So 4th root of 3, I see a 3 inside, no s's, all the s's came out, okay? All the s's came out, okay, and s squared, but there are 2 t's left over inside, so this t squared. All right. Again, and it gets more and more complicated after that, okay? Practice. All right, let's try here. 256. Okay. Again, I would start by, like, if it's even, it's a big number that you're not really familiar with, I would just divide it by 2. Same thing with this number, divide that by 2. And that becomes 2 and 64. Now I'm pretty familiar with that, and that's 8 and 8. Okay, and that's 4 and 2, 4 and 2, 2 and 2, 2 and 2. Woo. Okay, so now I broke that down. 1, 2, 3, 4. That comes out once. 1, 2, 3, 4. That comes out once. That looks like 256 to the 4th power. Looks like it's going to be just 4. Well, let's see. 4th root of 256. See, I would probably do that first to try to, to see like we did last time. But that's fine. We still got 4. Okay, 4 came out because it's 2 times 2. Now let's do, of course, for the s's, we're dividing 4 by 5. How many times is 4 going to 5 without going over? That's 1. So basically 1 came out, 1's left over inside. In, out. Okay, don't get it, you can get it confused if you don't do it enough. All right, and then for the t's, it's 4 divided into 7. How many times? It looks like 1, because 4 times 2 is 8. That is 7 minus 4 is 3. Inside, outside. Okay, so with the s's, 1 in, 1 out. With the t's, 1 out, 3 in. So we already have the 4 on the outside here. 4 s's, we said 1 came out, so it's 1s. T's, we said 1 came out, that's t. 4th root, no numbers are left inside, but we have 1 s out, 1 s left in, and 3 t's left in. Okay, so that's how we got that. And please do not think that I feel like this is easy stuff. This is not all easy stuff. Okay, let's move forward to the next situation here. We have 5 times the square root of 13 minus the square root of 13. In this case, it's going to be just like combining like terms. If they have the same number inside the square root, they are technically like terms. So although this does not have a 1 here, this is technically a 1. So it's going to be 5 minus 1. So the same way you would do, let's say 5a minus a to make it 4a. Okay, because I was thinking, this is my thought process about it. Same situation, 5 minus 1 is 4, and then the square root of 13 just stays the same. Okay, same thought process like that. So 4 times square root of 13 here, add the numbers, 8 and 8 is 16, 8 plus 8 is 16, and then the square root of 5. Because they have the same, they're like terms, you can just add them together, okay? If they didn't, you couldn't. So here, you'd have to simplify first. How do we simplify that? That becomes what? The square root of 9 times the square root of 2, and we know the square root of 9 is 3. So basically, this becomes 3 times the square root of 2. Plus, we're going to simplify square root of 25 times the square root of 2, and we know the square root of 25 is 5. So this becomes 3 times 5, okay? 3 times 5, because when it comes out, it multiplies by the number out here, 15 times the square root of 2. So 3 times 5 is 15. Square root of 2 stays the same. Now they have the same basis. Since they have the same basis, you can add them. This becomes what? 18 square root of 2. Okay, again, practice. Practice makes perfect. All right, let's look at this one. Let's break this down. This comes to square root of 9 times the square root of 5, plus 2 times the square root of 5 minus the square root of 4 times the square root of 5. So I broke 20 into square root of 4 times square root of 5. I broke 45 into square root of 9 times square root of 5. Again, that becomes 3. This becomes 2. Okay, 4 times 3 here is 12. 12 times the square root of 5 plus 2 times the square root of 5 minus 2 times the square root of 5. So then all of these have the same radicals. Since they do, you can add or subtract the numbers in front. So 12 plus 2 is 14, minus 2 is 12. So this all becomes 12 times the square root of 5. Okay, so we combine those because they have the same radical. All right, next page here says, we're going to do the star ones. Same concept. We are going to break these down. This right here becomes the square root of 9 times the square root of 5 times the square root of y. Okay, the y, don't forget the y, minus the square root of 4 times the square root of 5 times the square root of y. And again, if it comes out 3, 2, it comes out in front. The square root of 5 and y can't come out if it doesn't have an extra y with it. It has to have 2 to come out. So this becomes 3 times the square root of 5y minus 2 times the square root of 5y. Again, we can't take those out. So now that they have the same exponent, 3 minus 2 is 1. So the answer is 1 times the square root of 5y, which is just square root of 5y. Okay. All right, let's go down to the next situation going on here. Let me see. All right, so with this one, we will break 72. I will usually try to find a perfect square if I can. 9 is a perfect square there, times the square root of 8. 9 times 8. Okay, 8 actually has 1 in there too. This one is going to be 4 times square root of 2. So I wrote that down. And the reason why is because this is the perfect square, okay? So it looks like on this particular situation, oh, but don't forget the z's. Z is right here, so don't forget it has z cubed, which is z squared times z, okay? So that becomes now, let's bring all the ones out that should be out. So 4z is already out. This becomes 3 on the outside times 3. This came on the outside times 2. And that 1z came out because it's z squared. And remember, if you divide that by 2, it becomes 1. So this becomes z. What is left inside looks like 2 and 1z. Okay. So that is for that, just that one. We haven't even done this one yet. Okay, we haven't done that one. So 4 times 3 times 2, and then the z's multiply by each other. 4 times 3 is 12. 12 times 2 is 24. So this is 24z squared, and then 2z, of course. Now let's look at this one. On the kind of the other hand, and I don't want to go too far because I need some room for that one. It's going to be 8 is going to be the square root of 4 times the square root of 2. We know the square root of 4 is 2. And then z to the 5th becomes z to the 4th. And then z by itself, that you divide by 2. And it becomes all of the outside number, that becomes z squared. And this becomes 2z inside. Okay, so minus 2z on the out, 2z squared, and then 2z is left inside. So there are multiple things happening here. These cannot combine unless those are alike and the radicals are alike, because they have letters with them. Okay, so 24z squared minus 2z squared becomes 22z squared, and then 2z, because they have the same in the radical. Okay, again, not easy. That's a lot. All right, so let's look at this one. Same concept. I'm going to break 8y squared. I'm going to say this is 9 times 5, and then the square root of y is by itself. The y is by itself. Y squared, the square root of y squared is just, u squared is u. Okay, you should know that. Square root of u squared is just u, because with the 2 and 2 there, they kind of cancel each other out, and that just becomes u. Plus, we have u, and then you have the square root of 4 times the square root of 5 times the square root of y to the 4th. I broke that down and made 1 by itself. Again, we've been doing this a lot, so you should be able to kind of see that. All right, this becomes 3, it looks like. Nothing you can do there. That becomes 2. That becomes y squared on the outside. So all of the numbers that are on the outside, this one's 8. Y squared is already on the outside. The 3 came out, and the u came out earlier. U squared became u. And then 5u is left over inside. Now this particular, the u's outside, 2 came out, y squared came out, 5u is left over inside. Now let's pretty this up a little bit. 8 times 3 is 24. Okay, we have y squared u, and then the square root of 5u, plus 2y squared u, square root of 5y, sorry, 5y, not 5u. Okay, so now combine like terms, 24. These two, they are like terms, and they have the same radicals. So 24 plus 2 is 26. Y squared u, square root of 5u. Y. I apologize. Keep on reading. Okay. So that would be your answer there. You can only combine them if they have like terms in both places when they have the variables. Okay. Good. All right. Let's see if we can break these down. Again, if they're, I would just try, let's say cube root of 108, see if I can. Probably not. Nope. Let's break it down though. 108 divided by 2. We know it's 54, so it's going to be what? 54 times 2. I'm breaking this down to see what I can do. I know this one is 9. Sorry. 9 times 6. And 6 is 3 times 2, and 9 is 3 times 3. Okay. So looks like gatekeeper's 3 here. 1, 2, 3. It'll be 3, and 2 2's left over inside. So if 3 came out, 3, and then cube root of 2 times 2 is 4. Okay. I multiply these two together. 2 times 2 left over inside. There's not enough for it to come outside, so that becomes the cube root of 4. This 500 is 5 times 100. 100 is 10 times 10. 10 is 5 times 2. And same thing here, 5 times 2. So 1, 2, 3. 3 5s come out. Okay. Minus, it has a 3 already here. I'm going to write it down. Times, we said a 5 came out. And what's left over is 2 2s. Not enough to come out. That's 4. 2 times 2 is 4. Okay. So we know it's going to be cube root of 4 minus 15 cube root of 4. Same. So we can go ahead and subtract those. So 15, 3 minus 15 would give you negative 12 cube root of 4. That is our answer there. Okay. What's left over inside just stays, and we're done there. All right, let's move on to this particular problem here. Same situation. Let's see if that cube root comes all the way out. I don't think so. Maybe it was 4 it would, but let's see. 4, and then we're going to say root, sorry, 4, and then x root of 256. I don't think so. Yes, it became 4. Look at that. Oh, no. Oh, see, we did 4. 3 root of 256. Now, if it was 4, it'd become a whole number, but it's not 3. So let's divide 256. Let's divide that by 4, see what happens. Okay. See if we can kind of split that down. Yes, 4 and 64. So this becomes 64 and 4. 64 is 8 and 8. 4 is 2 and 2. Okay. That becomes 4 and 2. Same thing here. 2 and 2. And 2 and 2. That's a lot. Okay. That is a lot. So 1, 2, 3, that's 1. 1, 2, 3, that is 2 2s came outside. All right, I'm going to put them over here. So there's a 4 already out there because we're not doing this problem. So I'm going to kind of like extend it over here. There's a 4 already outside. A 2 came out. Another 2 came out. And what was left over is 2 2s. That's a 4. Okay. And then with this particular one, I can divide 14, and this is for my x's in this case. So I divide 4 by 3. I'm sorry. 3 is my root. That's my gatekeeper. I divide that by 14. Okay. Because I need to see how many are staying in and out with the exponent. So how many times does 3 go into 14? 4. Okay. 3 times 4 is 12. Subtract 2 on the inside. 4 came outside for the x's. So in that case, it'd be, what did I say? 2 inside, 4 outside. So x to the 4th is outside. And the inside would be x squared. Whew. And that is only for that problem. Let's move on to 108. I'll divide 108 divided by 2, and I get 54. So I'll break 108 into, what, 54 times 2. 54 looks like if I divide 54 by 2, I'll get 27. So 27 and 2 is 54. 9 and 3, and this is 3 and 3. Okay. So I 1, 2, 3, that comes out once. There's 2 2s left over. So for that number, I'm going to have 3 come out one time and 4 is left over inside. So 4. Okay. Now for the letter part, I'm going to have to take the 14. It's the same thing. We just did it over here where we're taking the 14 and dividing it by 3. So it gives you the same answer here, 2 in, 4 out. So 4 out and 2 in. Okay, so I put the same thing here and there. So now I'm going to put them all together here. 4 times 2 is 8. 8 times 2 is 16. I'll say 16. Okay, 16, x to the 4th. And then what's left over inside is 4x squared minus, I'm multiplying those together, 3x to the 4th, and then 4x squared. And then of course I can combine those two because these are like, and the radicals are, so this becomes 16 minus 3, 13, x to the fourth. And then the cube root of 4x squared is just comes straight across. Whew. Now that is practice. A lot of practice on that situation. Do not take that for granted. Those things are not easy. Okay. Okay, so for this particular one, if you put this in your no, you're not going to be able to put it in your calculator. You can put the numbers in your calculator, but basically all you're doing is that both are in the same type of radical. If this was a 3 and this was a 2, you couldn't multiply them together. But in this case, because they're both square roots, you can multiply 6 times 5. You get the square root of 30. Okay. If you can simplify that, you should. And 30, believe it or not, doesn't look like it, but it's true. You cannot simplify 30. So anytime you see square root of 30, you have to leave it alone. Okay. Anytime you're multiplying a square root by itself, so the square root of 5 times the square root of 5, okay, in this case, that's what squaring something is. Basically, what you're going to do is get whatever's on the inside outside. So the square root of 5 times the square root of 5 just becomes 5. Okay, basically it's the square root of 25, which is 5. So again, these kind of cancel each other out, the square root, and then square it, cancel each other out. That becomes whatever's on the inside outside. Okay. Here, let's go ahead and multiply them. 32 times 2 becomes 64. The square root of 64, and the square root of 64 is 8. So that's how we got that. Let's multiply 6 times 12, and we get square root of 72. Okay, see if you can kind of simplify it. Let's see. So 72 is 6 times 12. Then you break it down into 4 times 3. And I'd break this down into 2 times 3. And I'd break that down into 2 times 2. There's multiple ways you can do this. If I saw that 4, I'd say I'd take it out. But basically with this, it's the square root. So 2, 1, 2 becomes 1. And then there's another 2 3s come out. So I know that a 2 came out, a 3 came out. There's a 2 left over by itself. Square root of 2 is left over. 3 times 2 is 6. Square root of 2, that is your answer there. Okay, they did not want a decimal. Okay, and all of these are kind of like the same. Now, if I had to do something like this, before I'd start breaking them down. Before I put them together to be a huge number, I just start breaking them down to see, because we're multiplying, you know that all of these are kind of going to go together. So the 2 on the outside just stays on the outside, but the rest of this stuff is going to be inside the square root. So 75 becomes, what is it? 75 divided by 25 is 3, is that right? Yeah, so this is 25 and 3. 98, I divide that by 2, because, and then it's 49 and 2, which is, this is 5 and 5, 7 and 7, okay? But you don't really even have to, because once you get to a perfect square, and you're having a square root, you can just take it out. This becomes 5. It's the square root of 49 is 7. We know that becomes 7. So we know there's a 2 on the outside. We know there's a 5 come out and a 7 comes out. This 2 already came right here. Okay, so I took the square root of 25 and got 5, square root of 49 and got 7. 3 and 2 are kind of left inside by themselves. So 3 times 2 we know is 6. Okay, so 2 times 5 times 7 gives us 70. So 2 times 5 is 10, 10 times 7 is 70, and then the square root of 6. This would be your answer. And again, practice on that. Practice makes perfect, okay? All right, so with this one, it's just the same concept as I did up there. If you have 2 square roots that are multiplied, they're the same exact square root, and you're multiplying the square root by the same square root, it's just whatever's inside comes outside. That would be your answer. The square root of 7c times the square root of 7c is going to be 7c. Okay, you don't even have to do any work there. But for these, the numbers multiply by each other. Okay, and then if there was another letter here, you'd add the exponent, In this case, it'd be the square root of 30. And I said that earlier, the square root of 30 does not simplify. Okay, it looks like it does, but it does not. And then x. Can't simplify that, it doesn't come out. But look here, if you have 7z times 5z, 7 times 5 is the square root of 35. And then with this, z times z becomes z on the outside. Z times z is z squared, and z squared is just z on the outside. Anytime you see, so basically what you're doing here is 7 times the square root of 5, and then square root of z times the square root of z. Anytime you're multiplying, and I always like to put this so that you don't, you know, it's not a 2. Anytime you're multiplying these two, they're the exact same. It becomes whatever that is on the inside, outside. And 7 times 5 is 35. Doesn't simplify. Okay. All right. Another page down. Last page situation. Again, same situation. I can go ahead and do this middle one. Multiply the numbers. I would, if I can, I would start like breaking them down so that I know what's going to happen here, especially for the numbers, because you know that one's 5, this one is 3 times 5. Okay, these are the same, so 5 is going to come out one time, the 3 is kind of going to be left, so 5 is come, 3 is left. But the b to the 5th, I would add them. 5 plus 3 is b to the 8th, and then of course divide that by 2. Okay, so these, I'd add them. This one I kind of break down so that I know what's coming out, what's going in. All of, when you're multiplying them, they're all together. 8 divided by 2 is 4, so this becomes b to the 4th. All the outside numbers, b, 5 and b to the 4th go together, and then the square root of 3 is left over on the inside. It goes together. Okay. Same thing here. I would start breaking it down. 18 is 9 and 2. And then they have a 2 already that's there. These two look like they go together. They come out, and the square root of 9 is 3. Okay, that comes out to 3. That comes out to 2. So it's going to be a 3 and a 2 on the outside. The b's you add b to the 5th. Of course, with the square root, you can make it b to the 4th and then a b by itself. B to the 4th divided by 2 is b squared. So b squared comes out. And then the square root of b is left over inside. So this one has only a b inside left over. This one, the 2 came out, and the 3, the square root of 9 is 3, so it came out. So this becomes 6b squared, and then the square root of 6. Again, this is not like the only way to do this. There are multiple ways. It gets more and more comfortable as you do it. So make sure that you are practicing, okay? Again, here I would break it down into 9 and 2, okay? Break 18 into 9 and 2, and it's all in the radical, and there's already a 2 here. So this one becomes now 3, and that becomes 2 2s are there. Square root of 9 is 3. That's why I got a 3 there, and this became 2 2 became 2. So this is 3, and 2 came out. 3 came out, square root of 9 is 3. 2 2s that are alike, they come out one time. That's how that became 2. The b's, it becomes b to the 5th, and again, b to the 4th, and the v by itself, divide that by 2, b squared came out. B squared came out, and then there's a v that's left over. For the x's, x looks like x to the 9th, and you make it x to the 8th, and then the x by itself. Divide that by 2, x to the 4th came out, and then there's an x on the inside. So all the numbers on the outside go together. 3 times 2, and then the b and the x. So this becomes 6b squared, x to the 4th is outside. What's left over? bx on the inside. Okay. And I cannot lie to you, this stuff gets more and more and more and more intricate. In order to move forward and feel comfortable, please, please, please make sure that you are practicing in Alex and asking questions when you have them.